Alrighty, so yes, I had the other 5.3 solving systems by using elimination video. Um, I kind of actually wait. I need to go back. Sorry. So we kind of ended with this example 5 in the last video. I didn't get time to finish all of it, so I'm just going to go over example 5 one more time. Again, this is the 5.3 notes solving systems by using elimination, so 5.3. So basically, all we're really doing is using elimination that we've been using the last couple in the last video, and to solve this system out here. So again, what we want to do is we just want to determine a variable, the y's or the x's that we want to simplify or eliminate. And then from there, we just have to multiply our equations in order to match up in a way that they will, and they will simplify out. So again, I'm going to pick the x's. You could pick the y's if you wanted to, but I'm just going to pick the x's mainly because you already have one that's positive and one that's negative, so you don't really have to multiply by any negative numbers out. So I want a number that I can multiply both 4 and 3 by, that they could get the same number. And I know that if I multiply 4 by 3 and negative 3 by 4, I'm going to get a positive 12x and a negative 12x, which basically tells me that these are all going to simplify out. All right, now you can pick another number to multiply these by. However, you don't want to get your numbers really big, or else you're just going to get it's just going to turn out to be, bigger and bigger and kind of harder to work with. So we're multiplying this first equation by 3, and then we're going to multiply the second equation by 4. And again, when we multiply, we have to distribute to all of the terms, even the ones on the other side of the equal signs. So this turns into top equation, 12x plus 15y is equal to 105. And then negative 12x, and then plus 8y equals negative 36. All right, that's going to be a 1. Sorry about that. There we go. And then from there, once we see, hey, I got a 12x minus 12x, those are going to cancel out. Then from there, we just go ahead and add our system there. We're going to add those cancel out. 15 plus 18y is going to turn into a 23y. And then 105 minus 36 turns into a 69. All right. I divide out the 23 on both sides. I'm going to get y equals 3. And again, that is the y value of my answer there. Now, remember what I have to do now. I have to take this y, plug it back into one of my equations for y. And again, I just recommend choose the equation that looks easier for you. I'm going to use this second equation here to plug in for y. So I'm going to do negative 3x plus 2 times y, which is 2 times 3 is equal to negative 9. Turns into negative 3x plus 6 is equal to negative 9. I subtract the 6 on both sides. I get negative 3x is equal to negative 15, and then x is going to equal a positive 5. All right, so that's the answer for that one right there. Now, example number 6, it's again kind of the same process right here. I want to find a variable that I want to cancel out. And I see that automatically I have a minus and a positive with my y values. So positive and negative for my y values. So what I'm going to end up doing is I want to use my y values to cancel out. And it just so happens it's just kind of like over here. If I multiply this top equation by 4 and I multiply this bottom equation by 3, I'm going to get a negative 12y and a positive 12y. And again, let me go back real quick. And again, if you want to use your x's to eliminate those out as well, you can most definitely use those as well. I just kind of try to give you steps to make it a little bit easier for you to cancel out some of your numbers. And what I always recommend is, and it's not always just going to be negative 3 and positive 4, I would always look for, hey, is there an x and a y value that is a negative or a positive? All right, because that's just easier, to multiply by those numbers there. Unless if, you get like a negative like 115 and like a positive like, 206. Like you get like, if you see numbers like, even like the 7 or the 2 that, hey, I know to simplify those easier, you can do those as well. But again, I'm just going to use the y's right now. Multiply by the 4, I need to distribute out my numbers. So 4 times 2x is going to turn into 8x minus 3y is equal to 24. Distribute out my 3 here. I get that 3, I get a 21x plus 12y is equal to 3 times a negative 8 is going to be a negative 24. And then from there, we go ahead and add up our x's and y's, and we're going to go ahead and see that. So our y's cancel out. 21 plus 8x gives me a 29x equals, and look at this, 24 minus 24, those are also going to cancel out. So it's going to be 29x is equal to 0. And for my final answer, my x value is going to be 0. And then again, we need to take, gosh darn it, we need to take, come on, so now we need to take our x equals 0 and plug it into any of the equations. Again, I always recommend use the equation that looks easier for you, okay? Number 1, that kind of looks easy for me, so I'm just going to go ahead and plug 0 in for x, so it's going to be 2 times, again, I'm using this equation right here, so it's going to be 2 times x, which is 2 times 0, minus 3y is equal to 6. And then I go ahead and simplify this out. 2 times 0 is 0, so this basically cancels out, leaving me with just negative 3y is equal to 6. Divide the negative 3 on both sides, I get y is equal to negative 2. And that right there is our final answer solution right there. Alrighty, so now we have a couple more systems here using elimination, and these ones are going to be kind of more special cases, all right? These are going to be special cases, and you're going to see why in just a second here, because there's going to be some things that happen. So let's go ahead and do example number 7 here. So I have x and 2x, 10y and 20y. I need to find a variable to cancel out, and it doesn't really look like none of them match up, but I know that if I multiply this top equation by a negative 2, then this x will turn into a negative 2, which cancels out my variables. So I'm going to go ahead and then distribute it, the negative 2 to both the 10 and the negative 15. This becomes a negative plus negative 20y, or just, minus 20y, and then equals a positive 30. And if we look here, we're going to notice that, all right, so if you look, you're going to notice that, hey, this not only does the 2x cancel out, but the 20y minus 20y, those are also going to cancel out. So you're basically left with 0 plus 0, or 0 is equal to, and then we go over here, negative 14 plus 30 is equal to 16. Now, we kind of have to go back to our unit 2 to remember what happens when we have a final statement. When we cancel out all of our variables and we have a final statement of 0 is equal to 16, when our final statement is not true, what's going to happen there? Well, if we take a look, if we remember that if our final statement here is true, then we have no solution, okay? It's going to be no solution. And that's going to happen sometimes. Sometimes you're going to cancel out both of your variables in your system when you're using an elimination, and you're going to end up with no solution, all right? And you're going to end up with a final statement here, a number equal to a number. If that final statement is true, then it's infinite solutions. But if it's not true, then it's going to be no solutions, like we said right here. All right, so let's do example number 8 here. All right, I need to pick a variable to cancel out, and I can see that my 7x and negative 7x and 7x are going to cancel out. So I'm going to go ahead and just do those. So I'm going to go ahead and just add these together. I don't need to multiply by anything. I'm just going to add them all together. I'm going to get that 7x minus 7x is just going to be 0. Those cancel out. Hey, I look at here. I got a negative 1y plus 1y. That's going to cancel out as well. That's going to give me 0. And then I got negative 10 plus 10. That also equals 0. So look at this. I have canceled out all my variables. I have canceled out all my numbers. So now I'm left with a final statement of 0 is equal to 0. And we should know by now that 0 equals 0 is a true statement. So we have infinite solutions. All right. All right, so that is the video for, that's the final wrap-up video for unit, for 5.3. I will get, and also kind of the end of 5.4, I will get these other videos up whenever we go through them in class. Thank you guys for watching. Have a good day.